Hello, and welcome to this presentation on the 6.5-liter diesel engine with electronic fuel injection. Specifically, we'll address correction for several drivability conditions. These include poor throttle response, engine stalling, misfire, poor cold or hot start, extended crank on hot start, or start then stall on hot start. In addition, we'll also address two manual transmission specific issues known as decel stall and poor launch. All of the service procedures in this program are covered in a corporate service campaign. Customer letters will be sent out 1 to 2 weeks after the campaign has been issued to dealers. The mailing to customers will be rolled out in 3 phases by states in approximately 1-month intervals due to limited parts availability. As parts become available, additional areas will be added. Look for more information on this via corporate mail. I'm confident you'll find the following information very useful in your service department. So let's get started. In 1994, a new electronic fuel system was introduced on the 6.5-liter diesel engine to control fuel delivery, injection timing, and several other vehicle performance items. The movement to electronic fuel controls was driven by more strict emission requirements. One of the major advantages of the electronic system is flexibility. However, some customers may have experienced certain drivability conditions which causes them to be dissatisfied with the vehicle's operation. Therefore, certain service procedures have been developed to address these customer concerns. A service kit has been developed to help improve customer satisfaction with their vehicles. The kit contains a visor label with engine starting procedures, an optical sensor filter, and an injection pump housing pressure regulator. Additionally, new proms have been developed to help make the electronically controlled system operate more like the mechanical system that most customers are familiar with. Remember that the following procedures apply to 1994 Chevrolet and GMC models equipped with the 6.5-liter EFI diesel engine. Several different vehicle conditions can be enhanced with the service kit and service replacement proms. We'll look at the service procedures necessary to address these conditions. We'll perform our service procedures according to the sequence contained in the diagnostic check worksheet, which will come with the campaign bulletin. After service, this worksheet needs to be attached to the repair order. These diagnostic checks must be performed to qualify the engine support system. To begin service, you'll need to order the correct replacement prom for the customer's vehicle. To ensure that you order the correct service replacement prom, use the Tech 1 and scan through the data list display to identify the current prom ID. Cross-reference this with the replacements listed in the campaign bulletin. Realize that some vehicles may already have the latest prom available. Therefore, replacing the prom is unnecessary. Use the Tech 1 and look for diagnostic trouble codes or DTCs. Be sure to check for both current and history codes. If there are any stored DTCs, refer to the appropriate section of the 1994 diesel supplement, which was sent to all dealers in the spring of 1994. Correct any conditions and clear any codes before continuing. Next, verify that all engine electrical and ground connections are tight and secure. Be sure to check connections at both batteries, the ground connection near the alternator, and the PCM and glow plug relay grounds at the 2 intake manifold studs located at the back of the engine. Also check the braided ground strap, which is located either on the rear of the cylinder head or on the rear intake manifold stud. Be sure to check the relay center bus connection located near the fuel pump relay. Remove the air cleaner housing to gain access to the air filter. Check the air filter and clean if necessary. If the filter is excessively dirty, replace it. Remove the fuel solenoid fuse from the fuse block located under the instrument panel to prevent the vehicle from starting. Crank the engine. Use the Tech 1 to view the engine cranking speed. The cold start reading should be at least 94 RPM on the Tech 1, and your Tech 1 must have the April 1994 or later mass storage cartridge update to use this procedure. If not, use the procedure outlined in Section 6A of the service manual to check cranking speed. If the cranking speed is outside of specification, Use the procedure outlined in Section 6D2 of the service manual to correct cranking speed. Next, thoroughly clean any areas near the inlet connection to the injection pump to avoid possible fuel contamination. Then verify proper fuel supply pressure by installing a T and pressure gauge at the inlet connection to the injection pump. This will also check for fuel filter blockage, lift pump operation, as well as check the electrical circuit. Run the engine. With the vehicle at idle, fuel pressure should be a minimum of 3 psi. If it is not, check the fuel filter and fuel supply system as described in Chart A5 in the diesel supplement. Note that gauges with an inline orifice will not fluctuate like those that do not have an orifice and will be easier to read. Use a fluke meter, tool number J39200 or equivalent, to check glow plug operation according to Section 7 of the Driveability Emissions and Electrical Diagnostic Manual. Replace any burned out glow plugs as necessary. Once these service checks are performed and passed, proceed to install the service kit containing the visor label, optical sensor filter, and housing pressure regulator. Affix the label to the underside of the visor and install the previously ordered replacement prom in the PCM. Again, a list of replacement proms for all affected vehicles can be found in the campaign bulletin. Install the optical sensor filter by disconnecting the 6-pin optic sensor harness connector. Note the filter harness will need to be bent at a 90-degree angle and twisted to achieve a proper fit. Attach the filter harness to the optic sensor wire harness, and then the filter harness directly to the optic sensor connector. Next, install the housing pressure regulator by loosening the fuel tank cap to release any pressure. Thoroughly wipe down any areas near the fuel pipe and return hose connections to avoid possible fuel contamination. Remove the fuel return hose from the front of the injection pump, as well as the fuel return fitting and O-ring from the pump. Use a socket wrench to loosen the fitting. Use clean engine oil to lubricate the O-ring on the housing pressure regulator about to be installed. Do not use any thread sealer on the housing pressure regulator. Install the housing pressure regulator on the injection pump where the return fitting was. Use a torque wrench to tighten the fitting to 4.9 to 6 Newton meters or 43 to 53 inch-pounds. Next, install the 1/4 inch ID clear plastic hose to the fuel return fitting and secure the other end to the metal fuel return line. Make sure both ends of the plastic hose are tight so that air does not enter. Start the engine and look at the clear return line. Bubbles on startup are normal. However, if air is in the fuel system, bubbles like these will continue in the return line. Use the diagnostic procedures in Section 4 of the Driveability, Emissions, and Electrical Diagnostic Manual to correct the condition. A properly operating system will look like this. No air bubbles in the clear return line indicate the fuel system is operating to specification. Once the fuel system has been checked for air, remove the clear plastic test hose and replace the proper rubber return line. Tighten the fuel tank cap and start the vehicle. Check for fuel leaks. Next, warm the engine to normal operating temperature and check injection pump timing. Connect the Tech 1 to the vehicle. Activate top dead center offset learn from the output test injection pump menu of the Tech 1. Note that it takes about 20 seconds for the PCM to learn the top dead center offset. Allow the Tech 1 to time out. You can tell that the TDC Learn function is activated by the ON message at the bottom right portion of the Tech 1 display screen. Be sure to scribe a reference mark on the pump housing and flange before loosening the pump during timing procedures. This reference mark will allow you to see how much the pump has been moved and will aid in pump timing adjustment. If the engine stalled during TDC offset activation, slightly rotate the pump toward the driver's side of the vehicle with tool J29872. Then repeat activation of TDC offset learn with the Tech 1. If the learned TDC offset is between 0 and negative 0.50 degrees, the timing procedure is complete. If it is not, turn off the engine and slightly rotate the pump. Repeat the TDC offset learn procedure until the TDC offset value is within the proper range. Note that the Tech 1 will not display values less than minus 2.02 degrees or greater than plus 2.02 degrees. Therefore, if the pump position is outside this window, a pump adjustment may not change the Tech 1 display. This simply means to continue to move the pump further. Also note that rotating the pump towards the driver's side of the vehicle will produce greater negative numbers, and rotating it toward the passenger side will result in larger positive numbers. 1 millimeter of pump flange movement equals approximately 2 degrees of timing change. Next, from the data list display on the Tech 1, check the fuel rate for the vehicle. With the engine idling at operating temperature, the transmission in park or neutral, and the air conditioning and all accessories off, monitor the vehicle's fuel rate. A reading above 13 millimeters for manual transmission vehicles and above 15 millimeters for automatic transmission vehicles indicates a possible fuel concern like contamination. If this is the case, drain the fuel tank and fill it with qualified, known good fuel. The service procedure is now complete unless there is a concern of no hot start or extended crank hot of more than 4 seconds before starting. If the hot starting concerns exist, continue diagnosis by tightly blocking the radiator and bumper holes with cardboard or some other suitable object. Start the vehicle and run it in neutral at 3,400 RPM until the coolant temperature reaches 220 degrees Fahrenheit or stabilizes at a lower temperature as indicated on the Tech 1. Then shut off the engine and let it hot soak for 20 to 25 minutes. Use an accurate second timer and record the crank time before the engine starts. If the crank time exceeds 4 seconds, check the engine cranking speed. Use the Tech 1 with the April 1994 or later software update or the service manual procedure to check the engine cranking speed. Hot cranking speed displayed by the Tech 1 should be a minimum of 169 RPM. Realize that the Tech 1 only reads in increments of 18.75 RPM. This is why the 169 RPM reading is lower than the service manual specification of 180. If the cranking speed is outside of specification, use the procedure outlined in Section 6, D2 of the service manual to correct cranking speed. If the actual engine crank time exceeds 4 seconds and the crank speed is within specification, replace the injection pump. Contact your Stanadyne dealer as described in Service Bulletin number 376302 to order a new pump. When installing the new injection pump, line up the mounting holes one at a time by rotating the engine by hand. Use the alternator pulley bolt to roll the engine. Do not use the starter to rotate the engine. Doing so may cause the gears inside the engine and pump to be damaged or sheared. When assembling the air intake system of L56 turbo engines equipped with EGR systems, be sure to position the EGR tower gasket before installing the intake extension. Finally, after service is finished, be sure to completely fill out the campaign identification label. Each label provides space for the campaign number and 5-digit dealer code of the dealer performing the campaign service. Use a typewriter or ballpoint pen to fill in the information and affix the label to a clean, visible underhood location. When followed properly, we're confident that these enhancements will adequately address the customer concerns described earlier. That covers the service procedures for the 6.5-liter diesel EFI engine detailed in the campaign. General Motors is dedicated to providing you the knowledge, information, and tools to fix customers' vehicles right the first time. Repairing it right the first time goes a long way toward creating lasting relationships with your customers and repeat business.